Hello everyone, welcome to Clash Encoder. So in this video we will see the question number 153, that is find the minimum in rotated sorted array. So we are given a sorted array but it is rotated. So let's see the problem statement. So it is actually a medium level question. So suppose an array sorted in ascending order, that means increasing order, is rotated at some pivot unknown to you beforehand. So that means this is if for example this is an array that is sorted, but it is not actually that we are given. So we are given a rotated array. So we will be given a rotated array at some pivot point. So but we don't know that pivot point. If you see 1 2 0 1 2 and we are so our pivot point is 4. So actually if you see we are getting 4 5 6 7 and then we are getting 0 1 2. So that means this array is broken from this part. So if you see from 4 to 7 it is increasing, then after a break it is increasing from 0 to 2, but after this 7 it is decreasing actually. So that means we are given a sorted but a rotated array. So we don't know that 0 is our pivot, so we don't have any idea about how to search this minimum element. So actually we have to find the minimum element. So you may assume no duplicate element or duplicate exists in the array. So we have no duplicate, so we have to not take any tension of that. So actually if you see the basic solution that comes to your mind, the naive approach will be to linearly traverse over the array and search for the minimum element, but this will take O of n time, which will be expected but yeah, we can improve it, because if you see this is we are given the sorted array. So what algorithm uses the sorted thing? So if you see binary search actually uses the sorted array. So but it is not like the naive binary search approach will work on this. We will have to modify it, but actually if you see we can improve the time complexity from O of n to O of or actually O of log of n because of the binary search. So if you see this example we're given, so 3 4 5 1 and 2. So actually this array is increasing from 3 to 5, and after that it is again increasing from 1 to 2. If you see here the minimum element will be 1. So actually we have to use a binary search. So let's see how we can use the binary search algorithm on for this. So first of all I will explain you the binary search, actually the basic binary search, how it works. So the basic binary search approach will if you know, or if you don't know I will explain you, will be that we like if we given a target of 10, so we are given the sorted array. So actually if you see we are given a sorted array, so we find a midpoint. So we find a midpoint. For example, if our midpoint is this, so you can see midpoint is 22. If you see 22 is greater than 10, so we are searching for 10, and 22 is greater than 10, and we note that our array is sorted. So that means we won't be able to find 10 after 22 because all the elements are in increasing order. If 22 is greater than 10, so every other element after 22 will be greater than 10. So we have to search only till this before mid minus 1, actually from the mid index. So if you see we have to search on the left side, so then only we will get 10. For example, if we have like value of like 23 or like 29, so if you see 29, the mid is 22. So if you see 22 is less than mid, this value, that is target value, mid is less than the target value. So that means we have to search after the mid, that means on the right side, because before that all the elements are sorted, so they will be smaller than the target value. So that is what the basic concept that we use for the binary search. So actually we are eliminating the search space. So if we are eliminating the left side or the right side based on the target value. If it is greater than the mid, then that means we have to go to the right side. If it is less than, then we have to go to the left side. So let's see how we can simply use a binary search, like how we can do the binary search on the simple sorted array. So if you see, first we have to initialize the left pointer. So left pointer comes here and right pointer comes to the n-1 index, which is this index. So if you see, what we do is we have to run a loop while left is less than right. While left is less than right, till then only we will search our element. If we don't get this element in this loop, that means we don't have that element, so we can simply return the -1 after that. So what we'll do is we will calculate the mid. How we can calculate mid? Mid will be actually equal to the L plus R, that is left plus right, upon 2. So it will be 0 plus 6 by 2, that will be 3. So our mid will be 3 actually here, but this is a simple formula for the mid, but in this sometime overflow occurs. So what we have to do is we have to simply use this formula, that is left plus right minus left upon 2. So this is the approach or the formula that we should use in the questions where the overflow occurs. So mostly you should use this only. So actually if you see we have the two conditions before the three conditions actually. So if you see maybe if we are searching for 10, if either we are searching for 22, if we find the midpoint, so mid will be this. So we have to like check also whether this is equal to, actually mid will be our value that we are searching. So we are comparing the target element with the mid. So maybe it becomes equal to the mid. If you see, we have the target value as 22 and our mid value is also 22. So we can simply return the mid index. So this is the first condition, actually returning the value from the this point only. If mid becomes equal to the target, it is actually array of mid. This is not index. It should be actually array of mid. That is middle element that we are checking for. If you see here now, what will be the another condition? I told you we have to eliminate the search space. So that will be simply done by, we will compare this mid element. Mid element is 22 and array of mid. If array of mid is less than the target, that means it should come on the left side. If it is less than, for the example that I was talking about, it was 10. So 10 is less than 22. That is the middle value. So what we'll do is we will simply ignore the right value or the after the right value. So we'll do is we will simply set our, actually this was an array of mid is less than target. Okay, so array of mid is less than target. So actually in this so in this point it will check for the else part, because our array of mid is 22 and it is not less than 10. So it is not less than 10. So we will simply I was telling you, we have to eliminate the right side. So what we'll do is we will set this right pointer to mid minus 1. So mid was here, so it is no point of like comparing this value, because it is already greater than our search value. So we will set our right pointer to mid minus 1. Mid was here, so it got right got here. Okay, so this is how we are simply reducing our search space. So now our value will be left plus right, so it will be 0 by 2 by plus 0 by 2 okay, sorry, 0 plus 2 by 2, so it will be 1. So now our mid will be here, so it will come here. So now value is 8. If you see, value is 8. So now if you see here, our target value is 10. Now if you see in this condition, it is not equal to the mid. Okay, so now if you see, our mid is less than the target value. So yes, 8 is less than 10. So that means we have to increment our left pointer. So if we increment our left pointer, it will become mid plus 1. So if it will come at this point, so left and right will be both equal. So actually it should be equal. So both will be equal. So now if you see left plus right, so 2 by 2, 2 by 2. Okay, sorry, 2 plus 2 will be 4 and 4 by 2 will be 2. So we'll be getting 2 index. So if we will check, mid will be 2. So array of mid is 10. So yes, mid is 10. So now if you check this condition, array of mid is 10 and target is also equal to 10. So that means we have found our value by simply reducing the search space from the left or the right side. So we search on the one side only. If our mid element is less than the target value, so we go to right side, otherwise we go to left side and we check for the value there. If it becomes equal to the mid value, that means we have found our element. If we have not found if this loop ends and we have not got our element, so then we can return -1, because we don't have the element in our this array. So this takes actually log of n time. If you see, it takes log of n time. So we can like use this algorithm for searching in our sorted array, or which is rotated. So let's see how we can do that. So this was example that we were given 4, 5, 6, 7, and from this part it was changing or the pivot point. So you can see 0, 1, 2. So the minimum element here is 0. So we have to find the minimum element. So these are the indices actually 0, 1, 2, 3, and these are the array elements. So our algorithm will be actually similar to the binary search, but we will have to use more conditions in this actually to search for the minimum element, as we have not we don't know whether our pivot element is at mid or after that or before that. So let's see how we can do that. So what will be the conditions actually? If you see, so this is a basic step that we need to do, left and right, initializing left and right. So we will run the condition and then we will find our mid. So we'll check if our so in this example our left will be here, so left is here. If you see, left is here and our right is here. So left plus right, 6 plus 0 by 2 will be 3. So our mid will be at this point, so it will be at 3. So what can be our our conditions to find the minimum element? So if you see, we are checking this condition actually. So it really improves our time complexity. Actually you can check before this loop. You can also check if our array is sorted already. So you can check if left is less than this right. So if array of left is less than right, then we can simply return this index, starting index, because it is already sorted. So it can be also sorted in the question. So that's why I'm telling about this condition. So now if we are running this condition, okay, this while loop, so we check if our this array of mid is greater than array of mid plus 1. So our mid was here, that was 3. 0 plus 6 by 2, it is 3. So mid is our 7. So 7 is greater than 0. If you see 7 is greater than 0, what will be the condition to find the minimum element? So if you see, this is minimum element. So actually minimum element will be smaller than both the left side and the right side. If you see, this is actually rotated. So if you see, 0 is smaller than 7 also and 1 also. So this can be our one of the conditions. so to check for the minimum element. If you see it in this condition, actually by luck it got accepted, like this, we got the mid or the minimum element from this this condition only. If you see our mid element, that is 7, is greater than 0, so that means this will be our pivot point, because at any point it should be not it is like broken from here. If you see, it was increasing like here from 4 to 7, then it abruptly got decreased, so it got to 0, then it got to increase to 2. So you can see this is actually our, so you can see this is actually our point to find the minimum element. So we can simply return the mid plus 1. Our mid will be here, so we can return mid plus 1 as the minimum element that we have found. And the another condition that we will be having is, if for example we have more elements here, like 7 and 8 index, and we have more elements like for example 3, and after that also we have some element, so then our mid will be actually coming here. So it will be, let me erase these. So then our mid will be actually, if you see, our right will be here, okay, right, that is 8 plus 0 by 2 will be 4, so our mid will be coming here. So now if our mid is here, we will have to, how we can check if this is minimum element or not? We can simply compare it with both indices, or that or you can do check for the one index also, if in this condition that we are doing the same thing. So you can see numbers of mid minus 1, actually our mid is 0, so mid is 0, and the before element, the element before this middle is 7, so which is also greater than 0. So that means this can be our mid is our element that we are searching for, or the minimum element, so we can return the mid also. So you can add more conditions over here also, but it won't be necessary. If you can also add that this middle element is less than the mid plus 1 element also, but that is not required. So I hope you understood these two conditions. Actually these two are the conditions that really improve our time complexity, because we are getting the like mid element, we are getting the minimum element near the mid only. So now let's see the other conditions, how we will like increment our left and right pointers, so when we don't get our value. So for example, if we don't get our value over here after the mid also, if this array is different, so what we'll do is, if our like our mid is this, so our element we are checking for is like let's see. So actually if we have another element in between them, so then what we will do is, we will check if this we know that array is sorted, so we have checked for the condition before, and only if array is sorted but not rotated, so it will return the value. But in this case we know that array is sorted but it is also rotated, so that means we will not get our minimum element at this point. So we'll check if this point is less than the mid, so we will check if the numbers of left is less than the mid, so that means we will not get our minimum element till here, that is from L to mid. So we will not get our minimum element in between this, because it is rotated. So that means this is our increasing part, actually the part that comes afterwards. So we will simply set our left to mid plus 1. So we will have to search only for this point, if you see. So now we can add more condition also, like one more condition, that is if mid is right is also less than mid. So if you see, this 7 is also less than 2, so that means we will have a potential candidate for the minimum element over this part only, not this part, because this we can see is rotated. So that means we will not be able to find our value here. So that means we have to search for this part, actually the mid plus 1 part. So you can see what we'll do is, we will our left was here, so we'll increment our left to this point. So then our right will be staying here. If otherwise our this point, that is this value is greater, for example if it is like if we are on 0, for example our mid comes on 0, okay, so our mid comes on 0, then what we will do is, we will check if this condition is actually not true, because if you see left is not less than mid, so actually this condition will not be true. So what we will have to do is, we will have to decrement our right to mid minus 1. So actually it is similar to this normal binary search, but we have to only modify it or add some conditions to find this value, because we are not getting we don't know what is our minimum value, so we cannot like check for this condition if element is equal to mid value. This condition cannot be checked. So what we are doing is, we are checking these conditions, and here we are incrementing and decrementing our left and right pointers. Otherwise if we end this condition this loop and we don't find any element or the minimum elements, we can just simply return -1. So let's see the code actually. So I've written the code in C++, so I almost explained you the code in the algorithm only. So this is what I was saying. So first of all, the base condition can be, we are getting only the one element in the vector or the array, so we can simply return that element. Otherwise we can check if our first element is smaller than the last element. So actually, okay, so this should be coming here. So we'll check if our first element is less than the right element, or you can also write here left element is less than the right element. So that means our array is sorted but not rotated, so we can simply return the minimum element or the first element in the array as it is sorted. So then we have initialized our left and right pointers, so we will run the loop while left is less than right. So we will find the mid first of all, then we will check if the mid element is greater than the mid plus 1. That means that is the point of the like where our array is not increasing. Actually it gets to the decreasing point, that is 7 from 7 to 0. So that means we can simply return mid plus 1. Mid will be over 7 and mid plus 1 will be 0, so we can return that 0 value, that will be minimum. Otherwise we can check this condition. So if it is true, then it will return mid. If for example our midpoints come on 0, so we will check if the element before 0 is greater than 0. The mid element before mid is greater than mid. That means the mid is the minimum element that we are searching for. So that is another condition. And for incrementing left and right, we will simply check if the numbers of left is less than right, the middle. That means we don't have any potential candidate for the minimum element from left to mid, because it is a rotated part that should come afterwards, after the this sorted part, that was 1 2. So 3 4 5 should come after that. So that means before 5 we are not getting we will not get any minimum element. That means we are reducing our search space from this 3 4 5. We are cutting it and eliminating it, and setting our mid to this 1 to 2. That is from 5 to actually mid is at 5, so we will set left to mid plus 1, which will be 1. So otherwise we will set our right to mid minus 1, and otherwise if we don't get any elements we will return minus 1. So let's submit this code actually. So you can see we submitted the code and it got accepted. Let's submit it again, maybe the time complexity improves. So yeah, you can see now in this code, you can see we are almost checking all the conditions that can be possible. So now if you see, if you don't check this condition, it will also work, but we have to improve the conditions so that the most of the edge cases that we can think of, so our time complexity will improve. So you can see. So thank you for watching, guys. I hope you understood this video and like really understood how we can solve this example using the binary search, and it takes only log of n time. So I will share the code in the description also. Do like this video and subscribe to the channel. Thank you for watching, guys.